Welcome to the Explainer. So today we're going to talk about an AI model that's, well, it's kind of shaking up a core belief in the industry. This idea that bigger is always better. It's called DeepSeek 3.2, and it might just be signaling a huge shift in how AI gets built.
You know, for the longest time, the race to build the best AI was pretty simple. It was all about scale, right? More data, more powerful computers, and just absolutely massive budgets. Kind of like a brute force approach. But what if there's a smarter, more elegant way to get there? And this really sets the stage for what we're seeing now. It's like we're moving from one era to another. From what you might call the age of scaling, where you could basically just buy progress with a giant compute budget, to the age of research, where progress is earned through clever ideas and real architectural breakthroughs.
Okay, so let's dig into the problem first. The cost to train these top-of-the-line AI models it's immense. It's created this huge barrier to entry, making it an exclusive club. All the power has been concentrated in the hands of just a few very wealthy companies. But now, a new open-source model called DeepSeek 3.2 is coming in and directly challenging that whole setup. And their claim is pretty bold. They're saying it delivers performance that rivals the biggest names in the game, but get this, at nearly half the cost. So you gotta ask, how on earth are they doing that? Well, the secret sauce isn't more power. It's a completely new blueprint for how the AI processes information. We're talking about a fundamentally different and way more efficient architecture. Okay, the core innovation here is this thing called sparse attention. Now, instead of having the AI try to process every single tiny detail all at once, this system actually learns to intelligently focus only on what's most important for whatever it's trying to do. To really get a feel for how powerful this is, just imagine this. You feed the AI a massive amount of text. Let's say a context window of 128,000 tokens. Those are just little pieces of words. I mean, that is a huge amount of information for any system to try and chew through. Okay, now watch this. DeepSeek Sparse Attention looks at all 128,000 of those tokens, but it only keeps about 2,000 of the most relevant ones to actually work with. It just pinpoints the critical data and pushes the rest aside. Incredible. I mean, the efficiency here is just staggering. Think about it. This system intelligently throws away over 98% of the input data, and it does it without a big hit to performance. And that, of course, translates to a massive saving in computing power. And what's so cool about this is that it's a lot like how our own brains work, right? We don't get overwhelmed by every single detail in a room. We instinctively focus our attention on what matters. This AI is basically learning to do the exact same thing. But, a smart architecture is really only half the story. The next piece of the puzzle is all about how the model learns from its experience. And that brings us to something called reinforcement learning, or RL for short. So DeepSeek invested a huge chunk of its resources. We're talking about 10% of its entire compute budget just on reinforcement learning. Now, for an open source project, that kind of investment is, well, it's pretty much unheard of. And it's absolutely key for teaching the model how to do complex reasoning. One of their really clever innovations was teaching the model how to learn from the right kind of mistakes. So if you ask it 2 plus 2 and it says banana, cucumber, that's just useless noise. But if it answers 5, well, that's wrong, but it's a plausible, useful mistake. It's a good signal the model can actually learn from, which really refines its whole learning process. See, the old way of doing things had this huge problem. It's called catastrophic forgetting. When you try to teach an AI new skills one by one, it just forgets the old ones. You teach it how to code, and suddenly it gets worse at reasoning. Then you teach it how to use tools, and poof, its coding skills start to fade. It's a real nightmare. So DeepSeek's solution is pretty brilliant. They just sidestep the problem entirely. First, they trained up separate specialist models for things like math and coding. Then they took all the high-quality examples from those specialists and used that data to teach the final model all the skills at the exact same time. That way, nothing gets left behind. Okay, so all this new tech sounds amazing on paper, right? But the real question is, does it actually work? Let's take a look at the results, the good and the not so good.
Check this out. On a key benchmark for humanity's knowledge, DeepSeek 3.2 actually outperforms some of the top closed-source models like GPT-5 and Claude 4.5. I mean, that just goes to show you, on certain complex tasks, this new architecture can really punch way above its weight class. But to their credit, the team is super transparent about its weaknesses. Because it was built with less raw data, it just doesn't have as much general world knowledge. It can also be a little verbose, using more words than it needs to, and it can still struggle with those really complex multi-step problems compared to the absolute biggest models. So let's zoom out. What does this all mean for the future of AI? Well, the release of DeepSeek 3.2, it's more than just another new model. It feels like real, compelling evidence that we might be turning the page and entering a whole new chapter in AI development. What we're seeing is this fundamental shift, right? We're moving away from an era where only the players with the biggest, most expensive computers could even compete. And we're moving into an era where the best ideas can actually win. The advantage isn't just about raw power anymore. It's about clever, innovative architecture. And it's not just us saying this. Leading researchers in the field totally agree. The old recipes for building AI, they're just not enough anymore. They argue that true progress now demands genuinely new thinking, novel ideas, not just throwing more and more money at the problem. So here's the big takeaway. Smart engineering is now a direct competitor to raw computing power. A small, clever team can now build something that can genuinely stand toe-to-toe with the output of a billion-dollar data center. And, well, that changes absolutely everything. And that leaves us with one last, really fascinating question to think about. If smart ideas can now rival raw power, who's going to build the future of AI? As the playing field starts to level out, it might not be the usual suspects. It might just be built by anyone, from anywhere.